Bom, assistiremos agora a quarta e a última palestra dessa manhã, intitulada Vector Autoregressive Models in R, apresentada por Alessia Paccagnini, professora assistente na University College Dublin, onde é diretora acadêmica do mestrado em Finanças Quantitativas e co-diretora do Women in STEM Committee.
Hola.
Hola.
This is Alessia Paccagnini from University College Dublin.
I'm Fabio Parla from Central Bank of Ireland. Let me say that since I work for a central bank, the usual disclaimer applies.
So welcome to our lecture. So today we are going to talk about the estimation of a vector autoregressive model using R. So this kind of model is very, very important, and we need to thank this professor, Christopher Sims, who was also a Nobel Memorial Prize winner in economic science 2011. This professor introduced more than 40 years ago this kind of model in the literature of macroeconomics, in empirical macroeconomics and in econometrics, with this seminal paper entitled Macroeconomics and Reality. And what is it, VVR? So today we are going first to understand some aspect of this kind of model. And after that, after a quick theoretical overview about this model, we are going to understand how we can apply this model to identify oil price shock on the business cycle variables for US economy. And we are going to use R to understand the potentiality of this kind of model. So as we say before, this model is one of the best and most important model using in empirical application in macroeconomics and macroeconometrics. If you go on Google Scholar and you try to look for the paper, the seminal paper by Chris Sims, or you are going to introduce these keywords of vector autoregressive, you can find that this kind of models has a lot of citation, and is one of the most popular empirical model useful to try to reply to main questions, such as how much of an increase of a shock will affect the business cycle in the future periods, or what is it the contribution of a shock on observed fluctuation in the business cycle over time. And here in this slide, so you can find some key reference. Besides the seminal paper, there is another important contribution by Chris Sims with Stock and Watson, always published in Econometrics, about the use of this model in case of a non-stationary series. And Stock and Watson, in another important paper in 2011, 2001, try to overview what are the main potentiality of the vector autoregressive models. But one of the key and most important reference in these slides is the book written by Lutz Kilian and Helmut Lütkepohl. This book entitled Structural Vector Autoregressive Analysis is the source of our empirical exercise. And if you are working, for example, in a central bank or institution, you can find a very useful, the last but not least reference provided by Andrew Blake and Arun Muntax. This one is a handbook of using this kind of model, especially for central bankers, where you can find several applications, not only using the frequentist approach, but also using the Bayesian approach. So let's talk about the mathematics behind this model. So this model is a multivariate model. So it's a multivariate extension of the simple univariate autoregressive model. We can start to look at this formula where we have y, that is the vector of endogenous variables. So consider among these variables, for example, in our exercise, we have the oil price, the inflation, and the GDP growth rate. So the tricky part is that these endogenous variables depends on themselves, but in particular, they depends on their legs. So it's like an autoregressive process where we have one variable that depends on its legs. Here, all the endogenous variables depends on their legs and the other variables' legs. And is crucial the role of this impact matrix A, that is a matrix which is useful to understand and monitor what is it the relation between the legs of endogenous variables and the endogenous variables at the contemporaneous time, at time t. In addition, we can include the vector of a constant, but last not least, we have this element ut. This element in Econometrics is an error, and in this kind of literature is called innovation. This component is a multivariate and is represented by a multivariate normal distribution with a vector of zero mean, and the variance covariance matrix is not diagonal. So let's see what's going on in a very, very simple case when you are assuming just two endogenous variables. In this case, you have two variables, y1 and y2 at time t in the vector of endogenous variables. We have a vector of their legs. We have the matrix of the impact coefficient. We have the vector of constant. We have our innovations. We have the various covariance matrix of our U1 and UT. And we can see what is it, this specification. Last but not least, in this simple case, we are considering one leg. And we can see here, because we have just the first leg. And when we write a model with the acronyms VR, we can explicitate the number of legs in the parentheses. So now let's see what's going on in our presentation. So we are going to make an overview of our teaching materials, focusing not only on the theoretical part, but we are going also to look at our codes. And our materials is including our main code, which is our main script that contains all the command useful to estimate and use the VR model to understand the impact of a shock on a business cycle. Also, we are going to explicitate what are the main package you need, what are the functions that are useful in this implementation, and of course we are going to give you more information about data that are used in our illustrative example to identify the oil price. So now, Fabio, the floor is yours, so you can show us how does it work in R and how we can implement our VR model.
Thank you, Alessia, for the very nice introduction on the vector autoregression. So so let me explain first what we have as a teaching materials. So as Alessia anticipated, in the main folder, which is called SER, we will find the main script, which contain the codes to perform the empirical application. As Alessia anticipated, it's about the identification of an economic shock. It's a oil price shock. Together with the main script, we have also included three folders. In the folder called packages, we provide an R script where we can install the packages we need to perform the empirical analysis. We don't need much packages for this empirical application. There are 4 packages which are called matrix. Then we have EXPM. Then we have ggplot2 to plot the var tools. And then we also need to install grid extra. The second folder is its title function. essentially, we include some in-house built functions we have created ad hoc, and then we update from the main script. Let me say that both the packages and the functions are updated by via the main code. And finally, we also have our data. So the data contains 3 time series. So in the bar literature, they are called endogenous variables. In particular, we have so the data you will find everything in the slides. So the data are from an application that is included in a textbook that Alessia mentioned before. It's the handbook called Structural Vector Autoregression by Kilian and Lutpol. In particular, we draw from that empirical exercise, and we the original codes are in MATLAB, and we perform the same analysis in R. So the time series are includes the percentage change of the real price of oil. Then we have the GDP deflator inflation rate, and finally we have the real GDP growth rate. So the time span runs from so the data are quarterly, runs from 1973 Q1 to 2013 Q2, and the data are from Econometrics and the Federal Reserve Bank of St. Louis database. So let's move to the main code. So we now open the main script. So again, this empirical exercise is drawn from these textbooks, which is called Structural Vector Autoregressive Analysis. In particular, we have an economic shock, which is the oil price shock. In macroeconometrics, we generally are interested not on the reduced form innovations, but we are interested in structural disturbances, or the error in which we can attach an economic interpretation. There are several ways to identify this structural shock. In our case, the oil price shock. A review of the main identification scheme is beyond this class. So we only provide the simplest identification scheme, which is the so-called Cholesky decomposition. So it's a recursive scheme where we need essentially to provide an order of the variable such that the structural shocks of interest have an economic interpretation. So in this code, we after estimating the vector of regression, we perform some of the main tools that are used in literature. In particular, we perform impulse response analysis. We also conduct forecast error variance decomposition and historical decomposition. We will talk about each of the 3 VAR tools later. So the code essentially is divided into 6 sections. In the first section, we essentially we set first the work directory. And then we update both the packages and then the own functions that we have created. So as you can see, we have already updated the packages, and now the functions we have created are already imported. So the section number 2. We import the series, so the time series we need to perform empirical analysis. Again, we have 3 endogenous variables. The first is the percentage change of the oil price. Then we have inflation rate, which is proxied by the GDP deflator. And then we have the proxy of real economic activity, which is the real GDP growth rate. So first, we need to import the data set, which by construction has a data frame object. So these are the 3 time series that we import. We can plot the time series by using ggplot2. So ggplot2 is the package that we have already updated, and the function is ggplot. So using a loop, we can plot the 3 time series. So all the charts, all the time series are in percentage. So we have the growth rate, the percent change of the oil price. Then we have the GDP deflator inflation rate, and finally the real GDP growth rate. So the next section is essentially setting the var specification. So in this section, we can specify the var. For example, if we want to include an intercept term or not, then we can set the number of lags for the estimation. We also set the forecast horizon, which are used for impulse response and forecast error variance decomposition, and so on and so forth. So we are following the empirical exercise in Killian and Lutpold, so we use their var specification. So we have an intercept term, 4 lags, and then we use other settings, such as, for example, the confidence interval. In section 4, essentially, we estimate the var using OLS estimation techniques. So as you can see from the slide, but also from the references, the var can be estimated using OLS or maximum likelihood estimation. It can be also estimated using Bayesian techniques, but here we will focus on simple OLS estimation. The var can be estimated separately, equation by equation. So writing the var in matrix compact notation, it is possible to get the OLS quantities as in the standard way. So x transpose x inverse x transpose y will give our OLS solution for the slope coefficients and the intercept. Then we can also retrieve the reduced form residuals, which are correlated. So they are not used as a structural shock, but they are useful to compute them. And we can also compute the estimator of the variance covariance matrix of the reduced form residuals. So in section 5, we perform a structural dynamic analysis. So once we retrieve the structural real oil price shock, it is possible to compute, to construct some of the main var tools that are used in literature. So first, we need to identify the structural shock. As I said before, there are many identification schemes in literature. One of the most used is the one which is based on computing the Cholesky decomposition of the variance covariance matrix of the reduced form residuals, which is computed in row 137. So this is a very important step, because B0 contains the contemporaneous effect of the structural shock of interest, in this case, the oil price shock, on the endogenous variables. Once we have B0, then we can perform, for example, a structural impulse response analysis, which measure the effects of a shock, in this case, the oil price shock, occurring at time t on the expected values of the variables over time. And then we can obtain the error bands of the impulse response by computing a residual-based bootstrap. We set the number of replication equal to 200 just for the sake of time. We can compute also the forecast error variance decomposition, which measure the portion of the error variance in forecasting a certain variable due to a structural shock. So again, we can compute the point estimate together with the error bands by residual-based bootstrap. And finally, we can also measure the contribution, the dynamic contribution of the structural shock on the dynamics of the variables. And finally, in section 6, we plot all the results. So first, we plot the impulse response functions. So in this chart, we have the response of the three endogenous variables, so oil price, inflation, and GDP growth rate, to a one standard deviation shock in oil price. The blue line is the point estimate, while the gray shadow area are the 90% confidence interval computed by Bootstrap. In a similar way, we can compute the forecast error variance decomposition. Again, we plot the median, the point estimate, and 90% confidence interval. And finally, we can also plot the contribution of the oil price shock to the dynamics of the three endogenous variables. So as can be seen from the chart, the identified oil price shock contribute to the dynamics of the variable of the price of crude oil, while the contribution of the oil price shock to the other two variable is smaller. So thank you so much for attending the class. I hope you find this class helpful. Thank you so much.
So thanks, Fabio. Thanks, everybody. So see you next time. Ciao, ciao.
Ciao.
Convido agora para conversar com os palestrantes, nossos moderadores, o professor doutor Ariel Levi e o professor doutor Andrea Ugolini, professor da Universidade do Estado do Rio de Janeiro.
So, hola.
Good morning, Alessia. Good morning, Fabio. How are you?
Good morning. Fine. You, how's it going?
Thank you very much for your presentation. It's a very useful econometrics example in R. Now we come to question and answer session. I invite everyone to post your questions on the chat. Well, we have now we have two questions. Okay, you explain that you use the Cholesky decomposition matrix to calculate the contemporaneous effects. Would it be possible to use an alternative calculation?
So I will start. So thanks very much for this question. And in this exercise, we decided to use a Cholesky decomposition that is the most common used way to identify the shock. And in our code, we are writing the VR estimation by hand, in the sense that there is not a proper package so far, but you can see if you look at the code, we have line by line all calculation. And when there is a calculation of a Cholesky, you can substitute with another way to identify the shock. For example, you can use the long run restriction, the sign restriction. And we aim also to create a comprehensive package in R where we can use VVR with different identification strategies. And it's something that we have in our research agenda. Fabio, do you want to add something?
No, Alessia, I think it was exhaustive. So it only needs to be adapted. For example, if we want to include sign restriction identification scheme, maybe the empirical literature suggests the estimation through Bayesian techniques. But again, it depends on the research and empirical questions that we have in mind. This is only, yes, a simplified example.
Okay.
But thank you for the question.
We have another question. Would it be possible with this methodology to calculate the effect with different regimes, given the extended period of time you use? This is an exercise, but if I have another exercise, I suppose it's possible. But this is a question for you.
So thanks very much. I mean, from this exercise, you could, for example, investigate the different regime, for example, in an easy way using dummy variables, in the sense that if you use dummy variables, you can capture, and that is the basic thing that you can do. So usually in macroeconometrics, when you look at different regime, there are some non-linear model. This model is linear first, and it could be extended in a non-linear setup. For example, in a non-linear setup, you could have a threshold VR or smooth transition VR. And in this case, you need to introduce this non-linearity. Another alternative aspect that you can include is the kind of estimation, because we didn't spend a lot of time in the video, but there are in the slides some notation about the estimation, because in this exercise we followed the frequentist approach, including a maximum likelihood or less estimation. But if you look, for example, the Bayesian estimation, you can adapt this code, for example, considering time varying coefficient VR. Fabio, do you want to add something about nonlinearity?
No, thank you. Thank you much, Alessia.
Ariel, do you want to ask something?
Yes. We have a question from Stephen Dutt. What's the assumptions of vector autoregressive? How can we test it in R?
So Fabio,
Alessia, do you want to go?
No, go. You didn't speak a lot, so.
Thank you. No, essentially, so the vector autoregression is a multivariate extension of linear regression. So essentially, most of the tests that hold for linear regression remain valid as well for vector autoregressions. For example, this is a Gaussian model. So essentially, it rely on those assumptions. We can test. Let me just, for example, just highlight. We can test, for example, for autocorrelation of the error terms, whether, and this is, for example, related to the question before, maybe we can check whether the residuals display, for example, heteroscedasticity, so that we can adapt the model to include a switching in the regimes. For example, there are different ways for testing, but we can test, for example, using a simple log likelihood ratio test, whether the var is homoscedastic or it presents heteroscedasticity. So the model has produce a likelihood, log likelihood. So we can test for that.
Well, I could add the Granger causality test that is a proper of a vector autoregressive. And in this test, under null hypothesis, you are checking if the legs of the endogenous variables are explaining one of the other endogenous variables. So this test is something that is typical for VR models and is quite important. It usually is the first diagnostic test because if you reject the null hypothesis, and the null hypothesis is that there is not explication of legs, it means that you cannot write your VR. So it's one of the important tests. Yeah.
Okay.
So how, there is another question I see on the screen.
This one.
Yes.
Last.
How would you...
Read, Alessia.
Okay, sorry. How would you conciliate the amount of legs each indicated by different information criteria? So, very good question. So in this case, you can check different information criteria, KAIK, Schwarz, and I think that the first step is just to use these information criteria, and the second step also you can look the autocorrelation function for residuals to see if you need further legs. I can give you a very quick example before the end. For example, if you're working with quarterly data, usually if you read the papers, the number of legs is 4. And if you try to check, for example, with information criteria, sometimes you can find 2 on 1 leg. And even if information criteria can suggest to use a smaller number of legs, the tradition, in particular, if you are working with macro data and data about a business cycle, you should look at the frequency of a data. And for this reason that you are including 4 legs, for example. And it happened to me for a journal article. We introduced 2 legs, saying that, Akai and Schwarz suggest 2 legs, but the referees say, I don't care about this information criteria. Just keep 4 legs because you have quarterly data. So you see that sometimes you know that you need to make a compromise with a number of legs, in particular with a VR.
Yeah. Well, thank you, Alessia. Thank you, Fabio.
Thank you for the invitation.
Thanks for the invitation.
Vi ringrazio tanto per aver partecipato. Ci vediamo la prossima volta, magari dal vivo,
sì.
magari in Brasile.
Magari impariamo qualche parolina in portoghese, in brasiliano.
Ti faccio da traduttore simultaneo, tranquilli.
Obrigada.
Obrigada.
Thank you.
Thank you, everyone.
Bye.
Thank you for your presence.